Hello, everyone. Spud wanted to say hi real quick. Say hi, Spud. So today we're going to continue our work on applications of trig functions, but instead of Ferris wheels, we're going to look at other cyclical variations that can occur. So let me go ahead and present my screen. I always feel like my face is the weirdest on this thing. Okay, events that are cyclic, such as seasonal variations in temperature, can be modeled with trigonometric functions. The average temperature for Regina is hottest at 27 degrees Celsius, so that is our maximum on July 28th, and coolest at 16 degrees Celsius, that's our minimum on January 10th. Write the cosine function for the graph. Draw the graph that approximates the temperature curve for the year. What is the average temperature expected for October 4th? The average temperature is higher than 23 degrees Celsius for how many days? So we have a lot of questions we're answering here. Let's start off with the A value. Well, the A value is the maximum minus the minimum divided by 2. To 27 minus negative 16 divided by 2. This is 43 divided by 2, or 21.5. So that's my A. And this is going to be a cosine equation. So we're not going to worry about max or min, like if it's starting. It's just going to be a regular 21.5. And this is, when we get down to the C value, I'll explain why that's the way it is. So let's go to the B value. The B value is going to be your cyclical fashion. This is going to be, and this is A equals 2 pi over a year. Well, a year is 365 days. And there's no way to reduce this. Whenever there are questions that deal with values over an entire year, the period is 365 if they make no other mentions of anything. Now, C value, remember, this is your H. We're starting the graph on January 1st, so that is day 0. The maximum value where the positive cosine graph would begin is July 28th because that's the highest. So the number of days to July 28th. And what we're doing is the maximum is normally on this y-axis. We're saying how far has this maximum moved? And it's moved all the way to July 28th, which is somewhere over here. So we're going to have to account for that movement. So in January, there's 31 days. In February, there's 28. And we're going to be adding all these days up. In March, there are 31 days. In April, there are 30. Do you guys know the saying 30 days have September, April, June, and November? So April has 30. May has 31. June has 30. And in July, we're only doing 28 days. So we're going to add 28. And that gives us a total of 209 days, meaning our H is 209. And then our D value, remember that's our K, and we find that with our midline. And to find midline, we do 27, or our maximum, plus our minimum, plus negative 16 over 2, which is 11 over 2, or 5.5. So K is equal to 5.5. Now, we're going to write this, and we're going to write it as y equals our A, 21.5. It's a cosine function. So cosine, and then our B, 2 pi over 365. Theta minus 209. So you write the theta and the minus, oh, sorry. I thought you guys could see that. You write the theta and the minus 209 together in parentheses, plus our K, 5.5. But this 2 pi over 365 does stay out of the parentheses. Okay, let us put this into Desmos. So looking at Desmos, we have y equals 21.5 cosine 2 pi, wish there was an easier way to write pi. There probably is. I just don't know it. Divided by 365. Ooh, I don't want that whole thing divided. So we might be putting some parentheses around this. And then theta, or x, minus 209 plus 5.5. Let me get these. The reason this is having issues are because of these parentheses right here. So I'm going to take them away now, and we should be all good. Let's see, 21.5 cosine 2 pi over 365, x minus 209 plus 5.5. Let us see where this is. Ooh, This is a really big one. All right, and I probably could have kept those parentheses over 2 pi over 3. Let's see if I could have kept those. I don't like them because we don't use them in the equation. And see, it would have changed it. So don't keep those parentheses there. This is the function right here. As you can see, at 209, it has its maximum right there. That's how we know, because it's the 209th day or July 28th. Okay, so it says for C, to find the expected temperature on October 4th, first find what day of the year it is. Before we even start that, we're going to graph this really quickly. So coming back over here, we saw the graph. We know what it looks like. On the 209th day, we meet our maximum. Our maximum is 27. 209 is about here. This is not going to be an exact science here. It's about there. Our minimum, January 10th, is on the 10th day, and it's a minimum of 16 degrees. It's going to be about here. And then at 365 plus some, we're going to hit our other minimum. So this is going to look like this. It's not going to be great because I'm not the best drawer of these. But it's going to look something like this. Now, on October 4th, so we have 209 days to July 28th. Another 3 days takes us to the end of July. So that's 212 days, and we're at the end of July because there's 31 days in July. Then August has 31 days. September has 30 days, and we need to go 4 days in October. Now, when we add all those up, we get 277 days. So this is going to equal 277 days. And so we need to know when x is 277, what is y? So we're going to put x equals 277 in here, and we're going to see where they intersect. And that's at roughly 13.9. We're going to round. So the expected temperature is 13.9 degrees Celsius on October 4th, or on the 277th day. And then the next question asks us, using your TI-83, we're using Desmos, that's fine. Find the intersection points of the graph and the line at y equals 23. Because question D says the average temperature is higher than 23 degrees Celsius for how many days? So this whole area up here is higher than 23 degrees Celsius. So I need to know at 23 degrees Celsius, what do I get? So let's look. Celsius is y, so y equals 23. If I can put it in the right spot, y equals 23. And that's at 173 days. We're going to round. 173 days and at 245 days. So between the 173rd day and the 245th day, all of this is above 23 degrees Celsius. So how many days is that? Well, 245 minus 173 gives us 72 days. There are 72 days where the temperature is higher than 23 degrees Celsius. Okay, so looking at some more problems like this. The highest average temperature for the Edmonton region is 24 degrees Celsius and occurs on July 20th. The coldest temperature is negative 16 degrees Celsius and occurs on January 14th. Okay, so the minimum, January 14th, is 16 degrees about here. I might be a little bit off on that point. The maximum, and January 14th, so 14 days in, we need to find the maximum day in. So let's start with our A, our amplitude. It's going to be 24 minus negative 16 over 2, which equals 40 divided by 2, or 20. Our B is 2 pi over 365 because we're counting in days. Our C or our H, let's see. So I need to go to July 20th. Well, last time we went to July 28th and it was 209 days. This is 8 days before. So it's going to be 201. See what I did there? Helping us out. And then K is equal to our midline, which is 24 plus negative 16 divided by 2. That's 8 divided by 2, or 4. So as we write this, it's y equals A, 20, cosine B, 2 pi over 365, theta, H minus 201. Remember, we always subtract H, so, or do the opposite of H. So here it's positive, we're subtracting, and that allows us to move it right, plus 4. So at the 201st day, we have our maximum of 24 degrees, which is like right here. And then this is going to go like this. Again, I'm not the best at drawing this. I apologize. All right. So we draw the graph that approximates the temperature curve for the year. And we're going to put it into Desmos because the next question is, what is the average temperature expected for November 4th? And I'm going to help you out with the days here. So let's first put this into Desmos. 30, 2 pi, 201 plus 4. All right, so here is our line here. You can zoom in or out if you want to. Now, November 4th, what day of the year was that? Well, October 4th was the 277th day. And there are 31 days in October. So we're going to add 31 to that. 277 plus 31 would give us November 4th. Just using previous work to help us out. And I will get 308. 308th day. So we're going to put 308 in it for X because days are X. Time is always X. And I get that it is negative 1.4 degrees Celsius. I'm rounding to the nearest tenth here. So it's negative 1.4 degrees Celsius. And that's what I got. Now this time I need the average temperature is below 0 degrees Celsius for how many days? So I need this section right here and this section right here. But that might be really hard to determine. So what I'm going to do is I'm going to determine this section, just like we did last time, and subtract it from 365 to get the actual number. So I need this number and this number right here, and that's 0 degrees. I'm going to be real. You can find them out, but you can also just look on here. It's the 98th day because your zeros are always on your graph, and the 304th day. And 304 minus 98 should be 206, but I'm going to double check that real quick. 304 minus 98 is 206. We're good. So this is 206. So there's 206 days that have greater than 0. So how many are less than 0? 365 minus 206, which gives us 159 days. And again, I did that because I found all the ones greater than 0. That's 266 days. And I needed all the ones less than 0, which is the total number of days in a year minus how many are greater than 0 degrees Celsius. Okay, one more question. The following table gives you the average recorded monthly temperature throughout the year. So instead of days, we're doing months now, and there's 12 months, just so you know. Use the month number for the x-axis. For example, April is going to be x equals 4. So we have all this. What is the amplitude based on the coldest and warmest month and period of the function? So let's look at this. The coldest month is negative 16. So this is my minimum. The warmest month is July, and that's my maximum. So my amplitude is 22 minus negative 17 over 2. 22 plus 17 is 39 divided by 2 is 19.5. So we'll have 19.5 as our amplitude. All right, and we need to write a cosine function for this. Well, my b this time is 2 pi over, we're doing months, not days, so 12, which reduces to pi over 6. My h. Now, since we're doing months, we're counting in months. And this is the warmest. It is 1, 2, 3, 4, 5, 6, 7 months in. So my h this time is 7. And then my k is my midline. So we add these 22 plus negative 17 divided by 2, which is 5 divided by 2, which is 2.5. Which means my function is y equals 19.5 cosine pi over 6 theta minus 7 plus 2.5. Okay, let's sketch this graph. So my lowest is negative 17, and that's at 1. And 1, remember, because that's January, it would be, this is 5, 17 would be about here. My maximum at 7 is 22, which is about here. So as we go through this, will look like this. Now, how does the recorded temperature for September, so the recorded temperature is 15, recorded is 15, compare with the value from your equation? Well, we're going to plug September is the 9th month, 9 into this equation and solve. So let's first put this equation up here so we can also make sure we graph this correctly. So we have 19.5 pi over 6 minus 7 plus 2.5, and I'm going to zoom in. So I do not need it zoomed out so much. Okay, so if we look at the 9th month, which is right here, it should be around 11 something. Let's look. So x equals 9, and we get that the exact answer is 12.25. So equation answer is 12.25. So let's see. How do those compare? Well, the real is slightly off, mainly because we averaged max and min and didn't take into account all the other numbers. We just took into account the maximum and the minimum. Okay. You guys have an activity today. I hope that you guys have a wonderful day. I won't see you again till next week. So I hope you also have a wonderful week and have fun. Have fun. If I can get here. Bye.